Hello everyone, this is Singh and today we will be discussing one another architecture from Uber engineering blocks itself, where we'll be discussing one of the migration strategies. And like till now we have discussed couple of migrations and we have learned a lot of things like what are the strategies you should follow for the migration. But this specific blog has one more insight which I wanted to cover. It's pretty straightforward discussion, easy to understand, not much of the depth, but you will get the ideas of one more thing. So let's get started. And our entire discussion is based on the perils of migrating a large scale service at Uber. So this is basically based on a migration of one of the service, which is invoice generation service. Now this invoice generation service, as name suggests, right, it is responsible for generation of invoices. Now these invoices can be anything. Let's say trips are being booked, okay, or let's say these invoices are for the payments which are paid to the customers or the drivers, okay. So the idea of this system is that it is responsible for generation of invoices. Now we will discuss about few of the bottlenecks which were there in the existing system, which is called invoice gen. It was written in the Python. It's a single monolithic application to start with. There are no problems with the single monolithic application, but we will discuss about what were the specific bottlenecks in this architecture, okay. So first of all, there were a lot of modules if you talk about, right. So if you look at this particularly, there are a lot of module inside it. You have data aggregation, then you do some sort of validation, then you do deduplication checks, then you have number generation, render, store, all those things, right. There is a lot of logic that goes in. Now the idea is that the service was written 10 years back, so it's a decade old service, right. Now as and when the new business use cases arrive or like new requirements come in, it was becoming hard, to restructure the code in the existing system, okay, or like re-architect the existing system to serve the requirements. Like there, it required lot of bandwidth and it was not easy to do, okay. So the only way out of this was that you come up with a new service or new architecture which address the bottlenecks and also address a few of the limitations which team faced with the Python specifically. So Uber, like if you talk about their standard design philosophies or like language choices, most of the recent services which are written or like which are launched at Uber are written in Go. And so this is the pretty, what you can say, standard language which is used there. Now you want to address the limitations. First of all, you want to ensure that all the things which are there, or like all the new things that come in can be easily put up in the new architecture. So that's what you want. So let's quickly cover what were the motivation, okay. So we already discussed single monolithic service which is handling all the things. We if we want to do something or like we want to make it more modular, let's say of validation of generation specific logic, distribution of invoices documents, okay. It was Python service, so there was more resource consumption. We will talk about like how this service architecture helped them to reduce 90% of their compute resources. So it's quite huge, right. 97%. It was an older service, harder to build newer components. There were, in case we talk about database tables, there were like 12 tables specifically, right, and there were separate uh, data models. There were like total 7 data models which are managed, maintained across these different modules which we have: validation, generation, all those things, right. So in a nutshell, there were a lot of problems, and the solution was that you come up with a new architecture and then launch it, okay. So new service was launched in Go, which is called Invoicer, cool, which is serving a TPS of 300 PDFs. So basically, you have to generate 300 PDFs per second. Now, let's quickly talk about the idea of the how the system is working. So you get, like there are different systems which publish the events. You consume those events, and based on that event, right. So the invoice can be of separate types. So that is one thing. Another thing is the invoices can be country specific. Okay, not all invoices. You might have to follow certain government regulations for some of the specific to, which are very specific to countries, right? So the invoice don't have to be same. Let's say in India you are adding GSTI number. Okay, in some other country you might be adding some another tax number. So all those things, it could be different for every country, and then there can be different use cases which require different invoices to be generated. So that's the idea. And this architecture, or you can say the flow of code, remains same, right? So in a nutshell, again, if you talk about the overall idea of invoicing, it's just that you are executing a sequence of steps. So just a basic state machine. Okay, you are in a so first you start with the data aggregation. You need some data, right? You received the event, you don't receive entire data in the event itself. You have to aggregate data by calling to different systems. So you do the aggregation, then you do the validation. Okay, you need to do some sort of validation that, yeah, this is the document I have to generate, or all those things. Other thing could be that you have to figure out which kind of invoice you have to generate. So you need some kind of that logic, config based logic, which figures out that. Okay, deduplication is one thing, that you have to ensure that the number, invoice number which you are generating, is unique across the invoices you are generating. So if you talk about it in a summary, it's a state machine which you have to execute, and it will be pretty similar for older and newer system. Like the logic, the idea would be same. The way you have written the code can change. Okay, so moving back to our migration. So we have decided that we are writing a new service. Okay, that is done. We have written a new service called Invoicer. Great. One critical thing which I mentioned right at the start of video, that there is one specific thing, uh, very specific to migration, that how you want to do this migration. Okay, so there are two approaches basically. It's a component based, and one is flow based. Now in case of component, what you want to do is, we mentioned that there are multiple components in the system, right? There is generation component, there is validation component, aggregation component. There are multiple components. Okay, so one approach is that you architect your system, or like you launch your system component wise. Okay, so let's say you have your earlier system in which you do the aggregation. Now you are writing a new component for specific to aggregation, just the aggregation module. Okay, and then you are plugging that into the older service to get benefits of it. So in this way, if you do, like if you go via this way, like you can launch each of these components iteratively, and then you can continuously keep on getting the feedback. Another approach is flow based, that you do the design end to end. So let's say you did the design for the invoices which are generated for all the payments that are sent to the drivers. Okay, so this is one line of business. Okay, there can be multiple line of business. So you do this end to end, and then you launch it. The problem with that approach is it takes time to launch the entire flow, and it becomes hard to take a continuous feedback. That continuous feedback loop is broken. That's the main reason why component component based migration is finalized. You can deliver features iteratively, so continuous feedback loop is on. Single problem at a time, you are focusing on a single problem at a time, so you are not thinking the solution end to end at a time. If you are working on aggregation, then you are only thinking about that. Okay, uh, easier work parallelization. Now one thing also which you have to ensure while you are doing component is that later on you have to plug these all components together. So we mentioned that you can do them independently, right? But still, you should have basic idea about how your overall system will look like, so that it's easier to integrate at the later point of time. It should not happen कि you have developed all the components individually, and now it is becoming hard to plug them together. So to ensure that, uh, what Uber did, like in this scenario, the team did that, they created unified data models. Okay, so that ensured that the same data model is used across the module, across the components, across the modules, which ensures a seamless plugin. Okay, so that's the one idea, and that's the one thing that you have to take care of. Other they are pretty like what you say, migration strategy related, which we have discussed in previous videos as well, that you have to ensure traffic shadowing. If you haven't watched the previous video, I highly recommend to watch those. Multiple videos on my channel related to migration. So the idea is that you move or you send the production traffic to the newer system as well, and then you compare the responses of both these systems, how this system is working. So in this scenario, you can both test the features, like how the feature is working, as well as like you can do the load testing via the production traffic. So that's useful that way. So traffic shadowing is one thing. Another thing is validation, which I mentioned, right? What are the responses you are getting from both the systems? Are the same or not? Are you getting the expected output or not? So you do the certain validation. And then this is the general mechanism that you do to ensure that your newer system is working as per the expectations. Cool. What were the improvements in the newer system? So quickly discussing all the improvements which were done in the newer system, we discussed that unified data model UDM, which ensures that you are able to easily plug all the components together, and to also ensure that whenever you are making the changes in data models, you are doing that at one place, right? Earlier there were 7 separate data models depending on the module. So it becomes hard whenever you want to add a new feature, or like let's say you want to introduce a new field, it becomes hard to do that. So this helps. Unification of templates. So the what we are doing in this system, basically what we are doing, we are generating the invoices, right? We are generating the PDF documents, so they follow a certain templates. So there were multiple lot of templates which were created earlier, use case specific. Okay, now as part of this new architecture, what team ensured is that you generate a, or you come up with a generic template, okay, a root template basically, and which can later be extended. Okay, it's just, you can say you have parent class and then you created multiple classes out of it. So that way you are reducing the number of templates which you have to maintain. Another thing is configurations. Now whenever I say configurations, one of our use case was validation. Okay, one of our use case was validation, that you have to validate whatever data you have is present or not. Okay, that has to be present in the invoice before it is sent for printing. Okay, or the PDF creation. So these validation rules, whatever you have, can change over time. Okay, and they are specifically like the rules are basically given by the product teams, or like basically non-engineering team. Okay, so what we have to do is we have to update our code, or like wherever we are maintaining the configs, we have to update that. So it consumes the on-call bandwidth. Now, as part of the new architecture, uh, what we ensured was that these configurations are plugged out of the code, and they are directly given to the non-engineering team. Basically, you give those configurations to the product team to manage, and they can just play around. Okay, they can update the configurations. There will be definitely a place which is not mentioned in the blog, but you definitely have to ensure that the changes are done in the test before, then they are tested out, and then they are moved to the production. uh, Even if we are doing that via console to product managers as well. So this has to be ensured that a proper testing is done before they are moved to the production, so that entire customer base is not impacted for this PDF generation. So that is done. Another thing was database redesign. We mentioned that we had 12 tables. Now, like, you create tables as per your use case, right? It's okay to create more tables, but I mean, if they are not required and you can club them together somehow. Okay, you don't have to create an entire normalized version of tables as you read or study in colleges. That's not a good way to go about it. Okay, so multiple tables were clubbed together, and in final you have just 2 tables to summarize. Okay, two tables to serve all your use cases. By the way, if you want to understand more such things, you can read about these design choices which you make in my upcoming book, which is System Design on AWS, which is this. Okay, it is right now available on O'Reilly platform. Physical copy will be available soon in the next year, so stay tuned. You will see it soon in my hands. So yeah, but the idea is that you read lot of best practices in college, but they are not really applicable when you design the real systems. Okay, normalized, the one thing is that you create normalized databases, but that's not entirely a best practice to follow. Okay, so you take a what you say, a mid path to ensure that you are getting best out of the system. Okay, in the end you have to serve the customers. You don't have to show that I have 12 normalized tables. Great. API redesign was one another point. So earlier, whatever APIs which were there, they were kind of tied to the use cases. Okay, so and it was 10-year-old service, right? So a lot of things evolved over time. So generic APIs were created to ensure that more and more future use cases can be easily integrated and updated, and kind of making future proof. Let's after 10 years maybe you have to redesign this service as well. But yeah, impact, quickly discussing the impact: compute reduction by 97%. Great reduction rate. Lot of like saving of money. It's quite huge, 90% reduction in the compute resources. There was also a reduction in the resources of MySQL cluster, because you have reduced the tables, right? And you might have also optimized the queries which you have written alongside. So there is optimization in both reads and writes. If you talk about operations, then you have a config system which is entirely driven by the product or non-engineers. So you are saving your on-call bandwidth. So it's a pretty this is it in this architecture discussion. Pretty simple, I believe. And we had a lot of similar discussions earlier advice, but I want to specifically cover that component versus flow-based approach. So in this video, we will discuss this only, but there will be more such videos, and we will discuss more architectures from more companies. So stay tuned and keep subscribed to the channel. We will meet again in the new video. Not a nude video, new video. Till then, stay safe. Tata. Bye bye.